Okay. Moving to the next slide. Okay, right here, this is the unit circle. Okay, you can see that the center is at 0, 0. It has a radius of 1. That's the important thing about a unit circle. If you think of unit, 1 unit, we're thinking of a radius of 1. And you notice it goes out to 1 here, up to 1 there, to -1 there, down to -1 there. It's a really small circle, isn't it? Depending on your scale. My scale is kind of big right here. But a unit circle is really small, and we use it to define the unit circle, to define the 6 trig functions. Right here, what we do is we draw in an angle. I probably should draw this from the start rather than having it already up here. But right here, we take and we make an angle. So right here we have the initial side, and we turn this angle, so there's the terminal side. And this could be anywhere on the, you could turn any angle on the unit circle. And it creates an angle theta right here. Okay? So, and then we drop a vertical line down, and we call the point where it crosses the unit circle, we call x comma y. Okay? And if we drop a vertical line straight down to the x-axis, we create a distance x, and the side adjacent to a theta is x, and the side opposite, that perpendicular we drop down, is going to be y. Now at this point, I want to talk about the 6 trig functions. I want you to relate them to what we know about right triangle trigonometry. Okay, so we're going to start with the sine function, the sine of theta. Now, we all know that the sine of theta is equal to, I know you guys are still writing this, aren't you? Okay, yeah, so I'm gonna wait just a second while you guys finish writing this, and then I'm going to talk about it. So, we all know that the definition in right triangle trigonometry for sine is what over what? Opposite over hypotenuse. Okay? Now, well, if we look at theta right here, we've formed a right triangle, haven't we? By dropping that perpendicular down, that's the distance y. Okay, so we formed this right triangle. We know that opposite of theta is y, and hypotenuse is 1. Why is the hypotenuse 1, you guys? Yeah, it's the radius of the circle, isn't it? Okay, because it's a unit circle. It has a radius of 1. So my answer is opposite side is y. Hypotenuse is 1. What's y divided by 1, everybody? It's just y. So what you need to know is, everybody write this down, that the sine of theta, or the sine of theta, is the y coordinate. On a unit circle, the sine of theta is the y coordinate. You got to let that sink in. Think about that. The sine of theta on a unit circle is just going to be the y coordinate. So I want everybody to look up here at this unit circle for a second that I have on this poster. I used to have one on both sides. I probably ought to put one on the other side too. If you look at every one of these points out here, they have an x and a y coordinate, right? So if I asked you to find the sine of 60 degrees, raise your hand if you know what the sine of 60 degrees is. You know. Just raise your hand. I want everybody to have a chance to think about it. What did I just say sine was? Is the y coordinate. Here's 60 degrees. The sine is what, Kayla? Yeah, it's the y coordinate, square root of 3 over 2. That's it. Pretty simple, isn't it? That's what we're going to be doing today. One more time. Right here. We just defined this on the unit circle. The sine is defined to be the y coordinate. Okay? Here's x. Here's y. Sine was equal to opposite over hypotenuse. From theta, we have opposite side y. over hypotenuse, which is a radius of 1, right, on the unit circle. So y over 1 is just y. So the sine of theta is the y coordinate. So we come over here, we find, if I ask for the sine of 60 degrees, you look at the point for 60 degrees, and you find the y coordinates, square root of 3 over 2. We got that? Okay. So we're going to do the same thing. I want everybody, I'm going to have you guys in your groups. I'm going to give you 45 seconds. I want you to define the cosine of theta using the unit circle. Go. Okay, what did we define the cosine to be, you guys? Hey, eyes right here, please. Okay, everybody got x, right? Okay, because the cosine can be defined to be adjacent over hypotenuse. Adjacent side would be x. Hypotenuse would be 1. X over 1 is just x. So cosine theta is equal to x. Everybody write that down. That the cosine of theta equals the x coordinate. Okay, so I'm going to have you look at one over here. I'm going to give you, I want you guys to find the cosine of 300 degrees. When you know the cosine of 300 degrees, raise your hand. Just raise your hand when you know the cosine of 300 degrees. Okay, what is it, everybody? 1/2, because we go to 300 degrees, it's the x coordinate, right? It's 1/2, okay? All right, I want you guys to do the same thing using for the tangent, okay? In your groups, discuss the tangent. I'm going to give you 30 seconds this time. Go. Okay, you guys, what is the tangent, everybody? Y over x. Okay, everybody should have that one written down. Because the tangent of theta is equal to opposite over adjacent, right? So if I go tangent, if I look at theta right here, opposite side is y, adjacent side is x, so it's y over x, right? Any questions there? Okay, so I'm going to give you another one over here. This one's a little bit more difficult because you have to divide. But when you have the answer, I want you to tell me. I want you guys to tell me, by looking at this unit circle chart, what the tangent of 45 degrees is. The tangent of 45 degrees. When you know it, raise your hand. Tangent of 45 degrees. Hey, use your calculators. Put your calculators down. You don't need it. Tangent of 45 degrees. Okay. Looks like about half of you have it. What do you guys think it is? It's 1. Because if you go to 45 degrees, y is square root of 2 over 2, and x is square root of 2 over 2. What happens when you divide a number by itself? You get 1, right? Okay, good. That's the radian measure of an angle, you guys. So on a unit circle, if I asked you to find the sine of pi over 3, it's the same thing as the sine of 60 degrees. Sine of pi thirds radians is the same thing as sine of 60 degrees. They'd both be square root of 3 over 2. So I'm giving you guys the angles in degrees. The things with pi's, that's the angle in radians. That's the same angle, but in radians, which we talked about already. Okay, so if I ask you for the sine of pi over 3, you would give square root of 3 over 2. You go to pi over 3. Sine is the y coordinate, which is square root of 3 over 2. So you can use either radians or degrees. Okay? All right, so now we got to define secant, or cosecant, secant, and tangent. Well, you guys remember they're reciprocals of each other. So cosecant is going to be what? 1 over y. I want you guys, I'm going to give you 30 seconds to define secant and cotangent in your groups. Go. Secant and cotangent. Okay. Here's cosecant right here. Okay, you guys, secant. What did you guys get for secant? 1 over x, because it's the reciprocal of, secant's the reciprocal of the cosine, right? Yeah. And cotangent is the reciprocal of the tangent. So it is x over y. Okay? Oh, yeah, that's supposed to be theta. In trigonometry, they sometimes use x and sometimes theta. Cotangent theta is x over y. Okay, sorry. All right here, you guys, I'm going to start with this one right here. I want you guys to find the cosine of a negative 180 degrees in your group. Go. Okay, what do you guys think number one is? Does everybody get negative 1? Yeah, look, at negative 180 degrees, you turn clockwise. It's going to be an angle turned this way, halfway around a circle, right? That terminal side crosses the unit circle at this point, which is at negative 1 comma 0. Cosine is defined to be the x-coordinate, which is negative 1. So that's negative 1. Okay, I want you to find the secant of 90 degrees. The secant 90 degrees. Go. Now, as you guys find out, sounds like you guys all got it. It would be 1 over 0, right? Which is undefined. Cannot divide by 0. You guys, this happens a lot when you end up on one of the quadrantal angles, 90, 180, 270, 360. Because if you have a number divided by another one, there's some zeros in there, so sometimes you're going to get undefined. Okay, good. All right, let's do this one right here. The sine of a negative 90 degrees. The sine of a negative 90 degrees. Okay, what is the answer to this one? Is negative 90 degrees the same thing as 270 degrees? What do you think? Yeah, they're both going to have the same sign. So what is the sign? Okay, it's negative 1. Because if you go to negative 90 degrees, that would be in the clockwise direction right here. We'd turn it. We'd end up here at 270 degrees or negative 90 degrees. And the sign is defined to be the y-coordinate, which is negative 1. Okay? All right. Sorry, I forgot to turn that on. So if we look right here, we want to know how do they get square root of 2 over 2, comma square root of 2 over 2 for a 45-degree angle. So if we have a 45-degree angle, that's what it is. It's square root of 2 over 2 for x, square root of 2 over 2 for y. How do they come up with that? Well, they use what they know about the Pythagorean theorem. We know that the Pythagorean theorem states that a squared plus b squared equals c squared, or in this case, we put x squared plus y squared equals c squared. Well, we already know that on a unit circle, c is 1, right? So 1 squared is 1. Now, we also know on a 45-degree angle, that x and y are what? How do they relate? They're going to be equal, aren't they? Because this is half of a square. So I can call them both x or both y, it doesn't matter. And I have this equation right here. Now I only have one variable. I can solve for that variable. I can add those two together and get 2x squared equals 1. Divide both sides by 2 and I get x squared equals 1/2. I take the square root of both sides. Remember that? I take the square root of both sides and I get x equals the square root of 1/2. How do you simplify the square root of 1/2? Well, if you remember simplifying square roots, if I have the square root of 1/2, I can rewrite that as the square root of 1 or the square root of 2. I know what the square root of 1 is. What is it? It's 1. And then I have to do what we call rationalizing the denominator. Do you remember rationalizing the denominator? Yeah, you can't have a square root on the bottom, so we have to rationalize the denominator. How do we rationalize the denominator? We talked about this last time. Well, you times the top and bottom by what? Not 2. Yeah, the square root of 2. The square root of 2 divided by the square root of 2 is equal to 1, right? I'm going to erase this part right here. the square root of 2 divided by square root of 2 is 1, so I'm multiplying by a 1. It's just going to change the look of it because the 1 is not a typical 1. But I go 1 times the square root of 2 is square root of 2. And what's the square root of 2 times the square root of 2 equal to? Not 1, it's equal to 2. Because it'd be equal to, 2 times 2 is 4, it'd be equal to the square root of 4, which is 2. So do you see how, for x, we got the square root of 2 over 2? For both the x coordinate, and since they're both the same, they're both square root of 2 over 2. X and y, both of these right here. Would the square root of 2 over 2 squared equal 1? Times 2 equal 1? Square root of 2 over 2 squared times 2 equal 1? Well, yeah, it looks like, well, no. Yeah. So you have square root of 2 over 2 squared would be 2. 2 squared would be 4. Times by 2 would get 4 over 4, which is 1. Yeah, what brought that up? Yeah. Okay. Yep. Oh, yeah. Checking the answer. That's right. Well, you can use the Pythagorean theorem on every single one of them because every single one of them is a right triangle. Let me show you another one. Okay, so by the way, so the cosine of 45 degrees is what, everybody? What is the cosine of 45 degrees? Square root of 2 over 2. What's the sine of 45 degrees? Square root of 2 over 2. What's the tangent of 45 degrees? It's 1. Square root of 2 over 2 divided by the square root of 2 over 2, which is 1. Okay, let me show you one of the 30, 60, 90 degree triangles. And I'm just going to start off by talking about an equilateral triangle. What do we know about all three angles on an equilateral triangle? Yeah, they're all equal, but what are they? What's the measure of each one of them? They're all exactly the same. But what is that measure? 180 divided by 3, which is 60 degrees. So all three of these angles are 60 degrees on an equilateral triangle, right? Yes. Now let's say that each side of this equilateral triangle was 1 unit, because we're going to be putting this on the unit circle. Okay? Just guys, don't write this down. Just watch this. I want you guys to all watch this right here. I just want you to understand the theory behind it. If I split an equilateral triangle in half, okay, because these two sides are going to be symmetrical, even though my triangle right here doesn't look like that, but pretend like they are. What does this angle down here become? 90. What does this angle up here become? 30. It creates what we call a 30, 60, 90 degree triangle. Now you'll notice on the unit circle over here, if I was to go to the 30 degree angle, and if I was to draw a line from here out to 30 degrees, and then draw this perpendicular straight down, that's going to be a 30 degree angle, 60 degree angle, and 90 degree angle, right? Yeah. Same with the 60 degree angle. If I drew a line straight down from here, drew a line to the origin, I would have another right triangle. This one would be 60 degrees down here, 30 degrees up here, and 90 degrees down here. So we got 30, 60, 90 degree triangles. Yes. Exactly. Because, why? Yeah, if I just split this triangle in half, if this side is 1 unit and I split it in half, this side is going to be 1/2, isn't it? Now, if I was to use the Pythagorean theorem here, I have a hypotenuse of 1, an x of 1/2. How would I find the y? Okay, so I'd go 1/2 squared plus y squared equals 1 squared, right? Using the Pythagorean theorem. Well, 1/2 squared is 1/4. And 1 squared is 1. Minus 1/4 from both sides, we get y squared equals 1 minus 1/4 is 3/4. Take the square root of both sides, and I get y equals the square root of 3 over the square root of 4. What is the square root of 4, you guys? 2. So square root of 3 over 2. Now, I want you guys to go back over this unit circle. Notice that my two coordinates are square root of 3 over 2 and 1/2 on both 60 and 30 degrees. They just just interchange which one's x and y. And see, our two sides right here were 1/2, and this side would be square root of 3 over 2. So do you understand why on the unit circle the 30 and the 60-degree triangles have 1/2 and square root of 3 over 2? They just interchange? Yeah. Okay? Because using that using the Pythagorean theorem, we can figure those out. Now, on this unit circle that you guys are looking at, this is really important. On this unit circle, they only list what we call the common angles. 30-degree angles, 45-degree angles, 60-degree angles, and 90-degree angles. And every quadrant's the same. So in quadrant 1 right here, I have a 0, then 30, 45, 60, and 90. And then if you go 30 degrees beyond 90, you get 120. And if you went 45 degrees beyond 90, you get 135, right? And if you went 60 degrees beyond 90, you get 150. And 90 degrees beyond, you get 180. And it continues that pattern all the way around. So every one of these quadrants has a 30, a 45, and a 60-degree triangle inside of it, okay? And also a 0 and a 90. Now, we're going to be using reference angles to do a lot of the stuff we're doing today. But I'm going to go make copies of a unit circle for all of you so that you guys can all have that to use for your homework assignments. You can look up a unit circle on the internet anytime you need to as well. And I'll have these posters up here. But you guys are going to need to use the unit circle for everything we do from here on. So use that little copy I give you as an assignment. I want you guys, while I'm gone, I want you to use the poster unit circle up here. And I want you guys to find the 6 trig functions of 120 degrees. Find the 6 trig functions of 120 degrees. Now, you're going to have to remember we learned about reference angles last time. What's the reference angle for 120 degrees? What's the reference angle for 120 degrees? 60, exactly. Because if you look right here, you guys, 120 degrees, all eyes right here. I need you to see this. If I turn 120 degrees, I end up right here. Does everybody see that? Well, the reference angle is between the x-axis and the terminal side of my angle. So it's between here and there. Well, what's 120 to 180? Makes how many degrees? 60 degrees. Now, I want you to notice, though, this 120-degree angle, the x-coordinate, we went left, so it's what? Negative. And you can see it's a negative 1/2 up here. And the y-coordinate, we went up, so it's still positive. So every x-coordinate is going to be negative 1/2. Every y-coordinate is going to be square root of 3 over 2. I want you guys, while I'm gone, to find the 6 trig functions of 120 degrees. I'll make those copies. I'll be right back for you to use those. But in your groups, I want you to figure those out. By the way, I think this is one of your homework problems. So by doing this, you'll have a homework problem done. Okay. Hey, you guys, what did you get for sine? Sine 120 degrees. Square root of 3 over 2? Huh? Okay, cosine, what'd you get? Negative 1/2. Tangent. I don't really understand. Hey, look. Square root of 3 over 2 divided by negative 1/2. What do you get when you get a fraction divided by a fraction? You flip this bottom fraction and multiply it, right? So it's going to be a negative 2 over 1, right? Okay, Coach, let me finish this one. And those are going to cancel out, and you get negative square root of 3 over 1, which is just negative square root of 3. Get that? Now do the same thing with the secant and the cosecant and the cotangent. And then you guys, the cosecant of 120 degrees is going to just be the reciprocal, which is 2 over the square root of 3, right? But you got to rationalize the denominator. So you got to times the top and bottom by square root of 3, which is 2 square root of 3 over 3. Yes. Did you guys get that? So happy. I watched your video yesterday, and that's how I got this. Okay, good. Yeah. And secant's easy. What is secant going to be? negative 2. And cotangent, you guys, is going to be the cotangent of 120 is going to be 1 over the negative square root of 3. So what do you have to do to rationalize it? Square root of 3 over the square root of 3, which is negative square root of 3 over 3. And that's how you get the 6 trig functions. So you're going to have to know how to rationalize denominators to do this. When you take the ACT test, you'll need to know how to rationalize denominators. You guys, cotangent you could have gotten by going negative 1/2 over square root of 3 over 2, but it's easier just to take the tangent, which was negative square root of 3, and flip it over. Okay?
You know how you put the negative on the square root of 3 on the bottom?
Yeah.
It doesn't matter.
Yeah.
It's actually on the bottom.
Did you guys hear Trevor's question? You guys, it doesn't matter where the negative is, and this all means the same thing. Negative square root of 3 over 3 means the same thing as a negative out front, square root of 3 over 3, and it means the same thing as square root of 3 over negative 3. They all, you have a positive and a negative number being divided. They're all going to be the same answer, right? So it doesn't matter where the negative is. So you can move it up and down wherever you need it. Okay? Any questions? There's your assignment right there. Okay? I'm going to turn this off, so write it down quickly. This is part 1 of 5-3. Next time we'll add to it. Instead of just doing unit circle trigonometry, we're going to extend it out to say, what if it's a bigger circle? What if it's not a circle with a radius of 1? What if it's a circle with a radius of 5? Okay? Huh? Yeah, you could do that. Good idea. Okay, here's your assignment.